Hello everyone, my name is Blaine Greiner and I'd like to present to you all my entry into the Biodesign Challenge entitled Algae Flow Meditation, which is an exercise in design philosophy and a modular system for growing algae. So just a quick overview. Uh, so I designed this project to be a meditation in designing while working with biological entities. Um, And so over a period of 3 months, I observed and cultured an unknown sample of algae, which I think is chlorella. And from these observations, developed the initial stages of a modular, wall-mounted algae growing system. Um, I felt by taking a very slow approach in my design process, I was able to experiment in a meditative, intuitive, and responsive design practice, um, specifically tailored to working with biological mediums, which sometimes don't work at the same sort of rapid pace that we do when we're rapid prototyping. Um, so I'm not coming into this cold. I do have some prior experience in indoor grow systems. I've managed two big aquaponic systems from 600 gallons to 1,200 gallons in educational settings. And aquaponics is a symbiotic system for growing plants and fish for food. Um, and during my time when I was managing a larger aquaponic system, I also created a sunlight-based algae system for growing algae that sort of used aquaponics wastewater to produce algae and sunlight. And I mainly did this through using PVC pipes, a big plastic tank, a pump, and some softer, clear plastic rolling packaging pipe. Um, and so here's a picture of me. I think it's slightly staged for a photo shoot, but you get the idea. Um, so great, before we kind of dive into what the process became, I'd like to go into the design process. Um, so here's one of the experiments that didn't really make it into the final design, which was trying to isolate algae cultures on agar. Um, so yeah, so where I started off was step one. I started a culture and made some initial observations. Um, I received an unknown sample of algae on February 8th, 2022, and I spent several weeks observing the algae's reaction to changes in light, temperature, and various methods of air exchange. In addition to general observations, I noted that the algae flocked to the bottom of the sample tube in high heat, which I ended up kind of incorporating into my design later on. So here's a quick little example of the design process. I used Tinkercad to make my design for the algae scaffold. And the idea was to make something where it would have, I'll go into this a little bit more in the next slide, but sort of strike a balance between aerating, agitating, and also providing calm areas for the algae to sit and grow and culture. Um, so this is one of the many variations that I tried. And what I would do is sort of try one approach and then kind of observe what the implications of that approach was, and then try something different, um, and then make changes and print something else out. So I probably did about 3 or 4 iterations of the algae growth scaffold. Um, so here's the first step of the final design, and then I ended up enlarging it a little bit later. So based off these initial observations, I designed a growth scaffold with integrated air tube, which aerates and agitates the water while providing surface area with less agitation for algae colonization. And I I kind of gravitated towards parabolic shapes for their flow properties. So think rocks and rivers, bird beaks, Rudolf Steiner's biodynamic flow forms, which is a method of farming that's holistic, very similar to, I don't know, other sort of very deeply engaged farming practices. So I use these parabolic shapes, and the hope was that um, while the air tube pumps the air down to the bottom of the scaffold, the parabolic shapes would kind of fluff the air in and out as it went up the tube to agitate the water in the algae and expose all the water to the air. And at the same time, the inside of the parabolic cups would provide a nice kind of calmer growth place for the algae colonies. And so, yeah, so that was the first small version, but then I figured, well, I want to start growing some algae. So I used the bigger tube and expanded the growth platforms and made it a little bit bigger. So here was like an initial bubbling test of the growth structure, and I was pretty happy with how it turned out. So here you can see the bubbles, kind of, you can see like them kind of jutting in and out from in between the parabolic shapes, which is exactly what I want. Here's a little bit of a closer view. And there's the algae kind of whirling around in there. So this is the very, like, when I first kind of wanted to start really increasing the growth rate of the algae. The next step in the design process was another second period of observation and culturing of the algae. So after increasing the container and growth scaffold size, I further observed the algal culture for 2 additional months. And much to my surprise, the algae seems to be growing in a manner which utilizes the growth scaffold and is impacted positively by the initial design assumptions. So I thought that was great. And here you can see the algae starting to colonize the inside of the parabolic cups. So the next slide will be a couple of videos of, I think, maybe a couple, like a week or two after I initially transferred the algae into the larger container, and then an additional couple weeks later. So you can see in the first one, you can see some culture starting to form together. In the second one, you can see some really good algae clumps growing. So this whole period of observation, I really wanted to kind of get to know the algal biological entity that I was working with. So I wanted to take the time to really deeply engage with it and watch it and care for it. And I guess in a strange way, have it care for me. So with all this in mind and all my lessons learned, I designed an initial prototype for a modular containerized algae growth system. So I designed its 3D printable enclosure, which can be modified for different purposes. And so far, the initial designs include a bioreactor for algae growth with the parabolic growth scaffolds that I've been talking about. And another one that I've designed so far is a flow wall for aeration and sort of piquing human interest. And I wanted to design it so that these different elements could be combined in any number of given ways in order to change what somebody was looking to get out of the system, which I'll go over in a little bit. So here's a little demonstration. So there are some flaws in the system, such as the modules are a little bit leaky still. So I haven't quite used the algae and put it into the system yet, but I'm just going to use some regular plain water for the example. So first I'm going to start off with the bioreactor sort of extension. Put that in, and it's powered off with a little battery-powered air pump. So that will provide a great little bioreactor for growing algal cultures that you can feed through a bigger system. And then with not a whole lot to do, you could switch it over into the flow wall for human interests or another different way to aerate. And the flow wall is kind of a recent innovation, so I'm still learning about maybe what possibilities there are for it. But the whole idea behind this design process has been to sort of see what helps the algae to grow and then sort of just explore in a very natural kind of design style by making mistakes and taking advantage of things that are advantageous and kind of working forward through heavy accidents. And it's a little hard to see in this one, but now the flow wall is engaged. I'll have one later where I put a little bit of dye in there to help see the flow wall shapes. My idea is that once the algae we put into the grow wall system, it would start to also colonize the little parabolic shapes on the grow wall. So yeah, next I'm going to talk about applications. So the idea, again, is a modular system to allow for permutation. So a flexible, low-cost growth system which can serve a variety of functions, including interior landscaping, indoor air purification, sun harvesting, fertilizer generation from wastewater for gardens, and other things you do sort of algae for, food generation, and most importantly, creates opportunities for meditation and observation of slow growth cycles. Um, so algae by itself, I mean, I found it very interesting to watch and to watch it grow, and the whole growth process is very subtle, which is, I think, really exciting. Um, so here's another little just example of a little bit longer take of the bioreactor. So analysis, the potential benefits of this system would be showcasing a design philosophy, improvement of indoor air quality, harvesting of light, food production, human engagement with the sight and sound, and to create plant fertilizer from wastewater by having algae grow off, take the waste out of the water, and then using the algae to fertilize plants. Um, so a couple of the different modules that I have sort of in mind for expanding the system would be a filter system for filtering algae out, and then there's one other one that I can't remember right now. So I'll think of it in a minute. Uh, so for I think it's for food production mainly. And so having like these different sort of modules that one could design and integrate into the system to achieve all these goals. Potential drawbacks. The system might blend into the background if it's too stylish and it just kind of fades into an office wall or something. Um, Algae releases captured CO2 after it dies, so if it is going to be used for capturing CO2, there might have to be some really thoughtful strategies about how to harvest the algae while it was still alive and then put it into a form where it couldn't release that. Um, Another sort of drawback might be labor for upkeep. I don't know, I haven't yet kind of made a big system with enough modules to kind of feel what the workload would be. The potential to be too many things is always there with sort of a modular system. Um, and then the current design has flaws and can be improved in a number of different ways. Again, it's sort of hard throwing sort of a slow growth process up against a rapid uh, design process. And I feel like there needs to be some time put into this project to really develop the possibilities. Um, and then finally, there's probably similar systems that exist and similar in a lot of ways, maybe not exactly, but there's probably a lot of overlap with existing systems. Um, so here's a video of the flow forms with some dye in there so you can see the flow. A really cool thing about these parabolic shape sort of couples is that the way that they flow water around. So they flow water into the parabolic shape below it, but also to the one to the left of it. And so it kind of cascades down and to the left of the forms continuously, which I thought was really interesting. And that's an aspect that I would like to develop further in this particular module. Um, yeah, thank you all very much for watching. This has been my presentation, and please leave me any feedback. I'd love to hear your thoughts and appreciate your time. Thank you, and bye.